This protocol enables the information-directed assembly of oligomeric sequences by dynamic covalent interactions, truly mimicking the sequence-selective hybridization of nucleic acids, but with increased interstrand bond strength. Dynamic covalent assemblies are typically restricted to simple architectures, owing to their limited capacity for bond rearrangement and error correction. In contrast, by raising and lowering the concentration of a Lewis acid to affect bond dissociation and subsequently catalyze bond rearrangement, this technique mitigates the prevalent kinetic trapping limitations of these self-assembly systems.
This method could be employed in a variety of fields that utilize covalent bond rearrangement reactions, from covalent organic frameworks with exceptionally low defect rates to biomaterial tissue interfaces that are able to adapt and accommodate continued remodeling of the tissue substrate. When performing this technique for the first time, individuals may find kinetically trapped assemblies even after prolonged annealing times. We advise first-time users to attempt hybridizations between oligomers bearing exclusively aldehyde and exclusively amine residues, simplifying the encoded information and thus hybridization.
To begin this procedure, weigh 0.125 grams of FMOC photolabial solid support resin and add it to a fritted automated synthesizer reaction vessel. Insert the vessel into the microwave portion of the synthesizer. Fill the main solvent bottle with DMF and the deprotection bottle with a solution of 20% 4-methylpyperidine in DMF and empty the waste. Next, prepare 1 molar solutions of bromoacetic acid.